the scorching sun, the glint of salt on a sailor's parched lips, a dead calm, and the only sound is the creaking of the masts. The ship has become a floating prison, surrounded by an endless expanse of water that cannot be drunk. A hand reaches over the side toward the cool blue, but is stopped by a sharp cry from the boatswain. Drinking seawater is certain death. But what if I told you that on every pirate ship there was a hidden, almost alchemical device that turned this poison into life? In this video, we will reconstruct it. A gulp of salt water forces your kidneys into self-destruct mode. They try to filter out the salt, leading to organ failure faster than direct dehydration. The principle of distillation itself was known as far back as Aristotle in the 4th century BC, but pirates reinvented it in the hellish conditions of the open sea. Imagine your cells are freshwater fish. A gulp of salt water is like throwing them all into the Dead Sea. The salt literally sucks the life out of them. This isn't just a metaphor. Seawater contains about 35 grams of salt per liter, while our blood has only 9. It's like hooking up an IV drip of acid to your veins. And here's the paradox. To expel the salt from a single cup of seawater you drink, your body has to use 1.5 cups of its own fresh water. You are literally drinking to hasten your death from thirst. So what was this device? Simple boiling? Filtration through cloth? The answer is far more elegant and was hidden in the most unexpected place. To understand it, we first need to debunk the 3 biggest myths about survival at sea that millions still believe. The pirates' solution wasn't just ingenious, it was copied from planet Earth itself. They essentially created a miniature thundercloud right on the deck of their ship. It was their own personal, pocket-sized water cycle. The most obvious solution that comes to mind is to simply boil the seawater. Put a pot on the fire and wait. The steam rises, the water evaporates, but the salt remains. You don't get fresh water, you get an even more concentrated and deadly brine. It's like trying to make soup less salty by boiling the water out of it. You'll end up not with soup, but with a salt crystal. The result is what chemists call a hypertonic solution, a substance even more aggressive to your cells. All right, then the second myth, filtration. Running salt water through several layers of dense fabric. It seems logical. The fabric will indeed trap sand, algae, and debris, but not the salt itself. The salt molecules are dissolved. They are as small as water molecules. It's like trying to filter sugar out of tea with a flour sifter. It's useless. Sodium and chloride ions are thousands of times smaller than the pores in the tightest canvas. To separate them today, engineers use reverse osmosis technology, which requires pressure comparable to being 800 meters deep in the ocean. The pirates, however, had only fire and desperation. Now, pause for a second. Imagine you're on that ship. All you have is a barrel, a fire, and a wet rag. All the logical solutions have just failed. What is the most insane, illogical idea you would try to survive? Write it in the comments before watching further. Because it was precisely this kind of thinking beyond the obvious that held the key to salvation. Leonardo da Vinci, faced with such a problem, wouldn't have tried to improve the sieve. He would have asked, in what other form, besides liquid, does water exist? This very question leads us to the answer. The pirates realized the water didn't need to be cleaned, it needed to be stolen. Snatched away from the salt, leaving it behind. And for that, they needed a trap. A simple but brilliant trap for an invisible ghost, water vapor. This wasn't filtration, it was a heist. The plan was to make the water escape as vapor and then capture this fugitive, leaving its jailer, the salt, behind in the boiling pot. This process has a name, distillation. And you've seen it hundreds of times. When you cook soup, the lid of the pot gets covered in droplets of pure water. The rising steam leaves everything heavy, fat, spices, salt, in the boiling pot below. The pirates just needed to replicate this trick. And here's the irony. The same principle that saved their lives also gave them their favorite drink. Rum is also a product of distillation. The technology for making liquor became the technology for survival. The very word distillation comes from the Latin destillare, meaning to drip down. a perfect description for the life-saving drops of fresh water. The key wasn't boiling. It was cooling the vapor. Imagine the salt is like heavy stones at the bottom of a river, and the water is the river itself. When fire, like the sun, evaporates the river, the stones are left behind. The vapor, free of salt, hits a cold surface, instantly loses energy, and becomes water again. Drip, drip, drip. The water they obtained was so pure it didn't even contain natural minerals. For a person dying of thirst, it was a true elixir. And this is where 99% of pirate movies get it wrong. They show endless sword fights and treasure hunts, but miss the most important part. Survival at sea isn't about muscle, it's about intelligence. The historical accuracy of this method is a 10 out of 10. It's pure physics, accessible even in the 17th century. Similar desalination devices were described in the works of the Arab scholar Al-Kindi back in the 9th century. Their modern versions, solar stills, are still included in the standard survival kits for pilots and sailors in the U.S. Navy. The principle is clear. But theory is one thing. How the hell do you assemble this vapor trap on a rocking deck from scraps and rope? The design of this apparatus was brilliant in its simplicity and looked like something a mad alchemist would build. The main engineering challenge wasn't boiling the water, but sealing the system. Any crack was a leak of the precious water ghost into nothingness. Therefore, the art of building this device was the art of plugging holes, and for that, they had their own pirate superglue, a thick paste of flour, soot, and salt water. This is what the contraption looked like. We'll call it the ship's Alembic, a still born of desperation. At its base was any sealed pot, for soup, for tar, or in a pinch, even a cannonball split in half and cleaned out. On top was a tight-fitting lid with a single hole from which a condenser tube protruded. That's the entire design. The word Alembic itself comes from the Arabic Alembic, the name medieval alchemists gave their stills. They toiled for hours over flames, trying to turn lead into gold. The pirates weren't seeking gold. They were solving a more important problem: turning death into life. The first part is simple. The pot with seawater was placed over the galley fire. Then, the magic of sealing began. The seams of the lid were carefully sealed with that paste of flour and water, essentially simple dough. When heated, this bread-like gasket would bake, harden, and create an almost perfect airtight seal. It was a brilliant, unconventional use of galley supplies, pure pirate ingenuity. But the real trick was the tube. What was it? An old musket barrel taken from a decommissioned weapon, or even a piece of tarred canvas rolled into a sleeve and stitched. This improvised condenser coil was constantly doused with cold seawater. And here lies the cruel irony of the sea. The musket barrel, designed to take life, became a channel that gave life. And the monotonous task of cooling it, dousing a rag with salt water, was the most important watch on the ship. It was often entrusted to cabin boys, and the captain's own life depended on their diligence. Imagine the full cycle. Steam from the pot rushes under pressure into the cold musket barrel, and there it dies as steam to be reborn as water. Drip, drip, drip. This was the sound of hope, the most precious sound in the ocean, even drowning out the creaking of the masts. The process was agonizingly slow, perhaps 1 cup per hour. The first drops, containing rust and soot from the barrel, were mercilessly thrown overboard. They were dirty. Only the crystal-clear tears of the Alembic were collected in a shared mug. Now, look at this through the eyes of a 17th-century sailor. He doesn't know words like osmosis or condensation. To him, this is pure sorcery. He sees salty poison boiling in a pot, while pure, sweet living water drips from a rusty tube. It was more than just salvation. It was a miracle. It strengthened faith in the captain, who knew the dark secrets of the ocean. This secret was more valuable than any treasure map. Possessing it transformed the captain in the eyes of a superstitious crew from a mere commander into a shaman, someone who could bargain with the sea itself. This wasn't technology. It was power. The device worked, but it was no panacea. The harsh mathematics of survival tell us the answer is not so rosy. It was a deal with the devil. To get 1 liter of water, you had to burn scarce firewood, and firewood in the open sea was the ship itself, old planks, broken crates, unneeded parts of the rigging. The ship literally consumed itself to give the crew a drink. Most importantly, an open flame on a tarred wooden deck could turn salvation into a fiery hell at any moment. One spark, and the floating prison became a floating pyre. This is why this entire story isn't about salvation. It's about brutal selection. The grim arithmetic of the ocean puts everything in its place. Even the most efficient makeshift still could produce 5, maybe 10 liters of fresh water a day. For a crew of 80, that's 125 milliliters each, half a cup. Compare that to the standard ration in the British Navy at the time, 1 gallon, nearly 4 liters per person per day. This wasn't a life support system, it was a machine for postponing an execution. The truth is, this water wasn't for everyone. It was given only to key crew members, the captain, the navigator, perhaps the doctor. Those who could plot a course, read the stars, and get the ship out of the dead zone. This water wasn't for the sailors, it was for the ship's central processing unit. The common seamen were expendable. This transformed the still from a symbol of hope into an instrument of a cruel shipboard hierarchy where the value of your life depended on your rank. This principle is proven not only by history but also by modern experiments. Desperate survivors like Alain Bombard, who crossed the Atlantic alone, confirmed that a primitive still works, but its efficiency is negligible. A more famous example is Thor Heyerdahl's Kon-Tiki expedition in 1947. His crew faced the same problem and came to the same conclusion. It's a last resort solution, not a reliable system. So what was it? A real tool or just a placebo to give hope to the dying? Both. The main lesson of this story isn't about the liters of water produced, it's about the code of thinking that made it possible. The main product of this apparatus wasn't water, it was hope. Every drip into the captain's mug told the entire crew, we are still fighting. We have a plan. We have not given up. It was a cure, less for thirst and more for despair. This whole story boils down to a simple protocol, a code of pirate ingenuity that can be applied to any unsolvable problem. First, look through the problem. The enemy wasn't salt water. It was the bond between salt and water. The pirates didn't attack the water. They attacked that invisible bond. Second, use a phase transition. The solution almost always lies in changing the state of matter, liquid to gas, then gas back to liquid. And third, function is more important than form. They weren't looking for a distiller. They were looking for something that could boil and something that could cool vapor. It's like not looking for a key, but for a way to open the door. A crowbar, a lockpick, or a broken window are all working solutions. This approach is known today as functional analysis and is part of engineering methodologies like TRIZ, the theory of inventive problem solving. The pirates were intuitive TRIZ practitioners. This way of thinking is called first principles thinking. Don't try to improve the candle. Understand that you need light. This is how SpaceX engineers think today. Elon Musk didn't ask how to make rockets cheaper. He asked, what is a rocket made of? It turned out that the cost of materials is only 2% of its price. The other 98% is inefficient processes. He didn't attack the rocket, he attacked the process. Just as the pirates attacked not the water, but the bond between water and salt. What unsolvable problem do you have in your life right now? Try applying the pirates' protocol to it. Not, how do I make more money, but how do I create value that people will pay for? Sometimes, to find fresh water, you have to stop filtering the ocean and start catching the vapor. This protocol is a way to find the leverage point in any system, the point where minimal effort yields maximum results. The pirates understood that the leverage point wasn't filtration, where huge effort yields 0 results, but the phase transition, where minimal effort yields a 100% result. And now, the main question for you. What is more striking in this story? The ingenious technical trick itself, or the human will to live that forced its invention? What comes first? The spark of genius that creates a solution, Or the unyielding will that forces the brain to search for that spark until the very last breath? Write just one word in the comments, ingenuity or will.